over to the cloud with the engineers at Scribd. My name is Denny Lee. I'm the host for today's Tech Talk, and I'd love to introduce two of Scribd's engineers to talk a little bit about themselves. First, we'll start with Alex.
Hey guys, I'm Alex. In case you haven't heard of me yet, which you should have because you should have watched the previous video, I'm a software architect, a data architect at Scribd, and I'm a tech lead on data engineering team. I have a variety of experience in my years prior to that, but for the past somewhere around 5 years, my focus has been big data. And as I mentioned before, a big fan of Spark.
Thank you very much. That's awesome to hear. And so, Stas, why don't you introduce yourself and definitely provide a little background as well, please.
Okay, hello. My name is Stas. I'm a team lead on the data engineering team. I work with Alex. He provides the architecture for the migration, and we with the team implement it. So I worked with, for several years, I worked as a data engineer, and before that, I was a backend engineer. And data engineering is much more fun, I can tell you that.
Excellent, excellent. Thanks very much, Stas. So, okay, well, if you don't already know who I am, my name is Denny Lee. I'm actually with Databricks, so I'm different from these guys with the nice black hoodie. My past is, in addition to the fact that I'm a developer advocate here at Databricks, in the past I was actually on the team at Microsoft that created what now is known as Azure HD Insight. The reason I bring that little topic up is because we are, as this is part of the series of upgrading from legacy to the cloud. So if you hopefully you actually watched the previous video session, excuse me, with also Alex, as he alluded to, in where the Scribd was describing how they upgraded from their legacy Hadoop and Hive environments to the cloud, also using Apache Spark and various other tools. So let's go ahead and kickstart that process. Alex, why don't you, for those who may not have watched or need a refresher, could you remind folks on how and you perform that task of replicating data into the cloud?
The best advice I can give is just, hey guys, go watch the previous series, click like and subscribe to our channel. But other than that, let me give you like a high-level overview. We had to move our HDFS data to S3, and on top of that, we actually had to keep the data in sync afterwards because we didn't do a one-day migration. It actually took us a little bit under a year, but if you take into consideration all the planning and prep work, it actually took us a little bit over a year to get that done. So the process of our data sync was pretty straightforward. We were blessed with the fact that there was almost no direct HDFS access. All the access was done through a catalog, right, through table interfaces. And our data sync process in a nutshell was just reading data from our legacy system through table interfaces and writing them to S3 using table interfaces. The tables in S3 were now configured to use Delta under the hood. So yeah, so that was basically the process. One interesting thing to add to details that we haven't talked about in our last session, and it actually is important in the context of today's conversation. We don't shy away from writing metadata to Delta log. I mean, we write a bunch of metadata to Delta log. But one piece of information that goes in there is the user of the transaction. So the way our data sync operations work is that when we go and we figure out a list of tables which need to be synchronized, we also look at the last user who wrote to destination Delta tables. And if that last user was not data sync, our data sync will automatically pause and take those tables out of equation because it knows now somebody else touched them, so I shouldn't be synchronizing this data. So this will become more clear, I guess, as we talk about our entire migration process, but keep that in mind. We actually didn't have to manually go disable synchronization of specific tables because that would just happen automatically the moment we will write data to them from our new system.
Wow, that's super interesting. Okay, so then let's dive into some of those aspects, right? So, Stas, I think you had mentioned to me in the pre-conversation about things like, for example, how you didn't do the migration as a big bang, right? And as Alex had called out, right? There were no major interruptions. You preserved byte-to-byte output migrations, right? So why don't we talk about some of the key facets that you had to do in order to be able to achieve that goal in terms of doing the migration, so that way ultimately you could move those batch jobs from your on-prem environment to the cloud.
So one thing we wanted to achieve to basically don't distract business users from doing their job and just making them this migration as transparent as possible, which meant that every output table of every task should have the same output as in the legacy system, as in the Databricks. So we first thing we built the tool called Validator, which basically takes the diff of the previous snapshot states of the table and looks what changed and compares the change. And for example, like some tables are date partition, and we would compare only the latest date. And we did a bunch of optimizations. So we did hashing to reduce the amount of data we had to shuffle around and also reduce our data center transaction fees. So we we plan to open source it probably because it's not that trivial from the first look of it. But okay, so you have one legacy system task right into one output table, and you have this. Basically, you cannot, and you have the same task, also a different version of it, rewritten in Spark, for example, right into the same table. So how do we compare? We come up with this whole framework of called migration. We dynamically rewritten, not rewritten, but we added custom airflow operators which would detect, so this is a migration table, dynamically change the output of the tables, and then at the end of their pipeline, which is huge beast, more than 1,000 tasks, we would aggregate what tables were written to, and then we just batch compare them. And this is like the one piece, and we've discovered so many fun bugs and inconsistencies, just lists and lists of them. Maybe we'll share that as well.
Oh, absolutely, we should. So let's unpack some of the things you said, because you actually said quite a bit. And so, for starters, the first part where you're talking about basically looking at partition by partition and file changes. Just as a reminder, this is referring to Alex. Keep me honest here, but the DataSync application that you're planning to open source that was discussed in the first session about how you could check the files and check the checksums and validate that the data between getting a list of the tables that were on-prem versus the list of the tables that were in the cloud, and knowing how to synchronize those set of tables together.
So this is actually talking a lot. We had that. So there we were validating, making sure that the data that we copied actually matches one-to-one. But the next phase was, once we convert a task that's running in our legacy system and it's now running in our new system, we want to make sure that both of them produce the same output. So for a while, they cannot be writing to the same output location. So we created, what Stas alluded to here, we created this concept of a task being in a migration state. So when the task is in the migration state, it uses a special set of airflow operators, which under the hood substitute the outputs. So instead of writing to the real output, it will write to like a different location altogether. So now we have one set of data being data synced from the legacy system, another set of data being computed on the new system, and we can compare them basically partition to partition, and we get to decide how long of a consecutive successful validation days they have to have before we're comfortable switching them from this migration state to like, okay, now your real task, you're really writing the outputs, and the old task is no longer needed, right? So that's, I think, it in a nutshell.
Perfect. No. I think, Stas, you want to add to it, and I have a ton of questions. This is really interesting. So, but Stas, please, you start.
I just wanted to add that our data sync, we also did validation after that, but it was so rock solid, we didn't find any discrepancies. So it's not that useful if you have, yeah, if your code is good enough. But when you switch in frameworks, then you'll definitely find something. So that's more of a need for that.
No, that makes a ton of sense. And so actually, let's just unpack that little part a bit, because this reminds me of the old like data warehousing days, where basically when we migrated from data warehouse 1 to data warehouse 2, we actually basically ran two processes at the same time, and we just kept on overloading. And then we basically run a whole bunch of validation tests to say, hey, does the data match between the new one versus the old one? And so I take it you guys were basically doing the same process in which you would be able, in essence, you're A/B testing your own data, right? I think that'd be valid, right?
Yep, that's actually a good way to describe it.
So when you did that A/B testing, how long did you actually have to validate? I'm just curious.
Except we only picking B option, never A.
Got it. Okay, gotcha. No, that's completely fair. So, but what I'm curious about is how long did you actually typically would run the validation test? Like, was it by table, by business group? I'm just curious how did you organize it then?
Maybe I can respond. So basically, all tasks that produce some output in the data warehouse had to be validated. So as soon as validation matched, we just dropped the task in legacy system and just made the task in AWS non-migration, and that concluded the migration for that particular task. So it was as fast as possible, to answer your question, but it dragged on for quite a long time because we had to migrate a bunch of tasks.
I would augment that with not immediately, but as soon as we feel comfortable. We had some like heuristics for this, and those heuristics were really, if it's a daily task, let's wait to make sure it produces consistent outputs for at least a week, right? So we are running them in parallel in both system for a week, and we see, okay, they are producing output that matches, good to go, we can switch them. If this is a task that runs every week, we maybe will go ahead and say, well, 2 or 3 is enough because we can't really wait that long. And if it's something like a monthly task, then we take our chances a bit there, right? We'll let have 1 at most 2 consecutive matching validation runs, and we'll move on from there.
Right, but then by the same token, because you were running you had many tasks that you actually had to basically migrate, but then from your perspective, you were able to do many of them in parallel, right? So at least it's not like you were literally doing the serially one after the other, number one.
All right, so talking about converting and validating tasks in parallel, I think it makes sense to actually talk a little bit about our high-level approach to this migration, which we kind of skipped on, but hey, we'll talk about it now. So we had to migrate, I would say, roughly 1,500 tasks, right? And before we even talk about tasks, I want to talk about just overall, what were the workloads that we had to migrate? We had this big on-premise classical Hadoop infrastructure. We talked about how we moved the data, right? So that was just one part of workload. It was just a storage, right? So we moved storage, and we're now synchronizing storage. On top of that, we have 2 types of workloads. We have our batch workloads that run on Cadence, and we also have our ad hoc workloads where users will connect to clusters and run their queries, whether it is for the purpose of development or for some kind of ad hoc analytics that they're trying to do on the data. And we have another session planned to talk about how we did this ad hoc analytics, how we migrated those workloads. But it's important here to understand that those had to be migrated before we could start moving our batch workloads. The key to this is we wanted to avoid synchronizing data back from the cloud into our legacy system. So the synchronization was only happening one way. So that meant that once all the data is in the cloud and it's being synchronized, we can take all of our ad hoc workloads and just push them out there. So we can reduce the load on this cluster, maybe resize it a little bit, but more importantly, we can start computing the data out in the cloud without having effect on the users in our legacy system. So when we're talking about these workloads for our batch processing, as I mentioned, we have somewhere around 1,500 jobs. Interesting thing is that when we started taking inventory of them and saying who's going to be migrating what, we realized that we don't need to migrate like 200 of them. I was like, man, this is awesome. We should do this more often. We'll clean up our pipelines significantly doing it that way. But if you think about what were those workloads? They were basically initially you bring the data into warehouse. That would be things like scoops that will just bring your relational data in. We bring our data from our Kafkas. We'll bring in data from our some other proprietary analytics systems that we're using. Then we have a long processing phase, which is basically the core, the business logic, whatever the meat of these pipelines. And that's a mix of Hive jobs, Spark jobs. There were some jobs written in Ruby that would just like go read the data from HDFS, do something with it, record at a time, and then write it somewhere. And then at the end of the pipeline would be what I would refer to as our output phase. At the end of the day, all of these computations that happened, they have to go somewhere. So they would either go to tables that power some kind of business dashboards, or we will write this data back out to relational databases for the application to use, or we will go and refill some kind of like Elasticsearch indexes or Redis caches, whatever it is, right? So we did a bunch of computations, we inferred a lot of things, and we're now outputting it. So that was the gist of this big pipeline. So when we were thinking about how can we migrate it, going back to the original question, sorry, really long introduction here, guys, but we decided that in order to avoid copying data back to our legacy system, we have to start migrating from the tail end. So we would look at all the jobs that currently don't have any downstream dependencies in the pipelines, and we can migrate them. So when you migrate those, it opens up a set of jobs to be migrated that were prior to them. And as we do that, the synchronization of data, the amount of data that needs to be synchronized reduces over time until at the end, you basically no longer synchronizing any data and you're computing all of it in your destination system. There was a lot of words. I need to a sip of water now.
No problem. But that's actually a good introduction. We probably should have actually done that in the beginning. But it is what it is. That's what happens when you do a session like this. So nevertheless, this then there's two other points that I definitely want to call out that Stas had originally called out originally. So in the process of doing all of the migration, all of these tasks, right? First of all, the fact that even with maybe like you had mentioned before that maybe you'll wait a few days for daily jobs or a few weeks for weekly jobs and so forth. Right. The advantage of the approach that you had is that because there are 1,500/1,300 jobs that you had to move over, a lot of this could be done in parallel. So you could, with the framework that you've designed, you were actually able to parallelize that process. So that significantly sped things up, and then you're able to parallelize it because you automated a lot of the stuff. And so I think Stas, that's what you were starting to definitely had talked about in the beginning. So that's where I'm going to roll us back to, which is about that automation, right? You had specifically the things I think we wanted to call out was the automatic validation via custom Airflow operations and your templated SQL runner, because there were, especially from the standpoint of, Alex, you had mentioned originally about, it was great that you were able to query tables for most of this stuff, but you had Hive and Spark tables. Right, so why don't we dive into that one first, like maybe the template SQL runner, and then we'll talk about the automatic validation. So let's start with the template SQL runner.
Chime in here. So from those 1,200 tasks that we did have to migrate because they did have some business value, unfortunately, there were 700 of them which were just plain SQL template, which were run via hive-e command. Oh, well, basically first inside the Ruby template SQL files. We had to replace Ruby template values with actual values. After that, we could run it. And so we decided, okay, we'll do it via Python. Like we tried to run it via Airflow, but it looked like none of the existing solutions did what we needed to do. And we basically wrote two kinds of automation. First kind of automation is because we were running it by Hive, and Databricks platform does not support Hive, it only runs on Spark, so spark.sql method. We couldn't, like, we discovered pretty quickly we cannot just take that SQL render template and just shove it into that .sql and it will go smoothly. It will not go smoothly. First of all, it had to be one statement at a time. So we basically ripped off the parsing logic from Hive. Of course, we properly attributed it, but yeah, so we parsed it. Yeah, and after that, we just did a bunch of manipulations. Like one of the most obvious one, we used temporary tables everywhere, and we couldn't do it because Databricks only supports temporary view. So at the minimum, we had to replace those, right? But it wasn't easy as that because temporary table usually exists in some database. A temporary view does not exist in some database. You cannot put it in basically only default database, right? So we had to like dynamically find like is it like temporary table in some custom database, or it could be not specified. It could be in the use statement above. So we had to parse the whole thing, just find out all the instances where it used and just replace it. Or not. And there could be like multiple inserts per template, and we had to find like all the usages through the magic of regex. I'm actually very I don't like that code. We're not gonna open source it because it's just horrible. But it did the job, and now we don't need it anymore. And for everyone who just listening this, just use Antler 4. Just wrap your heads around that. Use that. But anyway, we just wrote the logic that parsed the Hive template, made hopefully runnable Spark template, which we could later split again on the semicolon, and run with Spark SQL each of those statements. One thing that's very beneficial. We could have just put every of those templates inside like Spark class, right? And just dynamically generate them or something and just hope it for the best. But templates are very useful, especially for business users. You say to them, oh, you have to like do it in Scala now. And they're like, whoa, hold on. we didn't sign up for that. So just to like, we wanted to be as transparent as possible. They shouldn't have felt a thing. Everything should have been done automatically. And it is. And we wrote, and actually this is like parsing, converting code. And second piece is the same thing. We parse it again to run it. And this time it's Scala compatible template, but bunch of things don't work exactly as we expected them to be in the Scala / Databricks / Delta Lake. For example, one of the important pieces were dynamic partition override. So we had to infer from the structure of the SQL what kind of insert it is. If it's dynamic partition override, do some magic under the hood, do some caching, figure out the values, shove it into the partitions. We use the replace where feature of the Delta Lake when inserting into Delta to find out exactly partitions. Yeah, I'm not going into details what the dynamic partition override is. Google it, and yeah, that's like, and we bunch of other stuff. For example, like well, I don't remember from the top of my mind, but there's like a bunch of magic out there. Maybe if it's useful to someone, we could open source it. Sure. Or maybe everything would be fixed and working out of the box, and everybody could just write spark.sql and it would work, which would be great.
No, well, I think everybody loves the idea. I think you're actually calling out the extreme importance of the fact that any migration job ever created has its own set of idiosyncrasies and issues. And so you're calling that out nicely. Yes, regex is both your friend and your hated enemy at the exact same time for precisely that reason. So I understand wholeheartedly what you're referring to. But I think in terms of themes, the call out here absolutely is that even with the supposed like similarity between Hive and Spark SQL, right? The reality is that there's a bunch of idiosyncrasies in Hive that don't quite match and that require quite a bit of time on your part to make sure that those two were in sync. So now that you basically have that templated SQL runner, right, to basically allow your business users to not write in Scala, right, and also be able to go ahead and just write SQL statements. Then there's also that automatic validation, which we had talked about before in terms of the customized Airflow operations. Can you provide a little context behind that again, if you don't mind?
Yeah, so I guess there are two pieces of customization. First piece, well, three. Okay, so ideally, at the end, we would have several types of Airflow operators. So one, it's like Databricks SQL runner operator, where we just point to like the name of the template, and it would run it. It would use Python, Airflow macros to just replace the macros we had in Ruby. Everything worked out fine with magic of regex again. So we now had Python, Airflow, Jinja 2 templates, and it would run that. So no problem. Second, we would have Spark operator. We also did a bunch of customization, integrated with monitoring system, etc. So we didn't use any out of the box. We had PySpark, which did a whole other thing, which like Docker containers and stuff. Also a bunch of Alex to say something. And yeah, we didn't have Ruby for a reason. We wanted to get rid of that, and we did. Congratulations. And yeah, so that's one piece, like what we wanted to have in production, the tools we would give our users at the end. Second thing, all of this, but prefix migration. So migration, Databricks SQL Runner operator, migration PySpark operator, migration Spark 3 operator, etc. So, and those would do what I described, like they would just replace, so in Spark 3 operator is harder to do to replace the outputs because you cannot inspect Scala and see what are the outputs. And we had to force our users to do like the thing where they have to specify this is the output, and then we could replace it. And for Spark SQL, we had all the power. We just analyzed it, magically replaced it. No one had to do a thing. Very useful. And yeah, PySpark, they probably did the same thing as Spark. Yeah, so this is the second piece, also a bunch of custom operators. But then we discovered that we want to do a bunch of more, like some of the teams raced ahead. So like maybe Alex will talk about this more, but at the beginning we thought, okay, we'll do it layer by layer. First, the tail end, the very last task, which have no downstreams. Then after that, next layer, the next layer. But some teams said like, no, we're gonna do it in 1 week. And they just migrated all of the tasks. And we're like, oh no, we couldn't, well, it doesn't work because it breaks the synchronization. As Alex said, as soon as someone writes from the migrated side, it automatically stops synchronization for not only for that task, for all the downstreams, which at that point weren't migrated yet. So it just did a bunch of super magic, like it's called trigger rule customization. So we just like this trigger rule would look what kind of operators it had downstream and like analyzed upstreams and decided, oh, I can trigger this task or I will skip it. And this allowed a bunch of teams independently to race ahead, migrating the tasks. And only like when data engineering said it's ready, we would switch over. I guess diagram would be helpful here. We have no diagrams. Use your imaginations. I'm sorry, actually, we should have diagram. Yeah. So like trigger rule, very cool thing. And yeah, at one point I had to like customize, like to allow the whole DAG to run, but also not run at the same time, and just be successful and allow retriggering, because we had like 10 teams at the same time doing their own thing, and coordinating that with those like customization was very helpful. And now we don't need those customizations. Yes. Okay.
I would like to add to some of this, maybe expand on some of these topics. So to start with, our custom migration operators in Airflow, they did multiple things. As Stas mentioned, first thing they were doing is looking for whatever the means were. We were finding the destination where they were writing, and we were swapping those destinations so that we don't accidentally overwrite the data that's being data synced until we're ready to. On top of that, those migration operators were actually using, just to be safe, we were running them in a context of AWS roles or users that didn't have permissions to overwrite the real data. So like this was really prevent, so we don't accidentally destroy something. And the last thing that they were doing, they were actually writing at the end of the run, they would write a piece of configuration somewhere saying, I'm migration operator X. I finished my run for date, whatever the date is, and my output tables are ABC, right? So at the end of the entire DAG run, we have another DAG that kicks off our validation DAG, and the first thing it does, it goes checks this configuration and says, okay, these are the things that I have to validate for today, and it will just go pick up and do those validations. So like all of this was automated where users just had to do the migration. And as long as they're using the right Airflow operators, all of the safeguards and automatic validations were provided to them as a side benefit. So yeah, this was pretty good. Another thing that I want to talk about here is, as Stas alluded to, is it wasn't just us doing the migration of all of those tasks. There was a bunch of different teams. We tried to migrate as many things as we could ourselves, but at the end of the day, not everything is a SQL template. There are some Spark jobs with lots of logic in them. There are some Ruby jobs that have to be migrated to Spark jobs, to which also have a bunch of logic in them. And we didn't feel super comfortable taking over this migration because we don't really understand what the job is doing. So the teams that originally wrote them had to chip in and do their work. And it very quickly became a nightmare for us to just keep track of what's being migrated, what's where, and we realized that we need a way to keep track of all of this. We need a way to tell teams, hey, you can start working on this task because this is the task that's blocking a lot of other teams from doing their migration. And we used the most powerful UI tool there is. We basically extracted the list of all the tasks into a Google Sheet, and we basically let the teams keep track of statuses there. But then we did, I guess nobody thinks of this, but you can actually use Databricks notebooks to bring Google Sheet data in as well. You have to do a bunch of API calls and security tokens, but at the end of the day, we were able to bring this data into a Databricks notebook. We were able to parse our DAGs in both legacy system as well as the new system. So we have, and then we join all of this data together, break it up by teams, do a bunch of pretty graphs, so teams can see where they at, how many tasks they have remaining, whom are they blocking, what's the most important thing to work on next, and Stas did a bunch of customizations to that later. I think we also integrated all of the validation statuses for all of those tasks in that dashboard. So it quickly became it quickly went from like the total wild west to a semi-wild west. So it's a wild west with a bunch of pretty graphs, basically. That's what it is.
Well, just as long as you have the pretty graphs, right? That's the important thing. No, but no, I say it in jest. So there's a lot to unpack with everything you just said. So, but let me see if I can possibly sort of like provide a theme here, which is that because you have all of these tasks that are running, what you basically had to do is you had to basically make it self-service, right? You had to make it so that way individual teams could actually go ahead and do the migrations without actually necessarily having like a full queued structured flow, right? That they could actually figure out where they were. And then it actually going all the way back, it started with not just the templates that you were doing, but basically building these customized airflow operations, these DAGs, where each migration task itself would go ahead and produce a bunch of, in essence, metadata, right, to tell you what's going on. And these airflow tasks that would then read that metadata to validate. So meta, right? And then once it did all of those things, yes, whether it's Google Sheets or Databricks notebooks or whatever else, but what ultimately happened was basically these beautiful graphs of DAGs that tell you which set of tasks actually were migrated, and then for any team they'd be able to go ahead and figure out where they were so they could go ahead and pseudo independently work from each other. Would that be right from a nutshell, or am I missing some tasks here?
In a nutshell, yes. I mean, the devil is of course isn't in the details, and some things did break, but there weren't any like massive breaks for us. We as you mentioned, lots of metadata and really safeguards. Was self-service with safeguards really was the key to this, right? So that if they shoot someone in the foot, it's only themselves that they shoot in the foot. They don't shoot everyone else in the room in the foot.
Got it. So what's interesting here is that the discussion we're having here about like guardrails, for example, it's very microservices-ish, like very in terms of thinking, where basically like independent teams working from each other, but then your job is to basically put these guardrails up so that way they don't go completely, off kilter. What I'm curious about is that from your team's Stas, whether it's yourself or Alex, yourself, are from your backgrounds, were you originally database people and then you transitioned to microservices and big data, or were you always like thinking from a very microservices perspective to begin with? Independent small teams with guardrails. I'm just curious because like there's always that monolith architecture versus microservice architecture, and often when it comes to data, especially if you're coming from database world or data warehousing world, we often default to that monolith architecture, even though it's like that doesn't work so much for anymore. Or like not, at least not all the time.
So in my past, I had quite a breadth of experience, and I would say I've seen a little bit of everything, and I created strong opinions on different approaches. And yeah, had to work with microservices architecture probably 4 or 5 years ago, and it's not all rosy. I mean, it's all good, but it's hard to create a localized development environment with 20 microservices running, trying to do an end-to-end testing. But anyways, yes, my background has been in classical databases. Then I moved more into like an application developer, more in than service developer, distributed systems, and yeah, microservices are cool.
No, makes sense. I'm actually, Alex, you and I actually have very similar backgrounds from that standpoint. So yes, I completely rock you. Where like, I'm not one to say it's all about microservices. I'm just simply saying like it seems like if you were to also only go in the database world and you were trying to do that, we would actually try to migrate 1,300 tasks all at once, right? In the monolith perspective, which that probably wouldn't work either. So
this is actually an interesting point because. One of the things that we were looking at when we were migrating this gigantic DAG of 1,500 minus something tasks, right, is that we initially looked at can we actually break this thing up into multiple DAGs, because it's insane to try to keep track of all of those things and all of these dependencies. And when we were evaluating that in the original system, the answer was a hard no, because when you have everything in one gigantic DAG, you can start on tasks much sooner, because and we had performance issues where our pipelines will take very long time to run, and if we try to break them up, the tasks would have to otherwise wait much longer to kick off. So, but when we moved, at the end of the day, when we moved to our new platform, we were able to slice off like at least like 200 to 300 tasks into a separate DAG that can run independently. And because now all of these tasks are running much faster, for multiple reasons. We can't afford that. We don't have to basically rush to start a task. We can choose simplicity of maintenance over performance here, because we no longer have those like very slow pipelines.
Oh, that's super interesting. Actually, I want to dive into that a little bit. But before I do that, Stas, how about yourself? I'd love to know a little bit about your background in relation to this, this transition. Like, did you always come from a, more application or services development background, or did you come from a monolith architecture background before you started this?
Both. I worked in Java background with monolith architecture, and then like a bunch of Spring Boot applications. Fun to create, not fun to test. And Spring Boot here, yeah, it's fun. Yeah, I had my there here and there, but I would say that in this particular instance we had no choice. Like it was so knowledge was distributed so widely, and as Alex said, we couldn't break it up into pieces to just do in parallel or separately with other teams. Yeah, we had to rely on other teams because of we didn't have all the knowledge, and it just the load was too much. Yeah. And now we're thinking about breaking up our big kitchen sink deck, that's what we call it, into multiple pieces. And fun fact, now it's so large, GitHub refuses to index it. It's almost 0.5 MB big, and we have to do it for one reason or the other. And yeah.
That's actually pretty cool. I have been guilty of placing very large files into GitHub for various different reasons, but yes, I understand exactly what you're talking about. So, in terms of trying to wrap things up for at least today's session, it seems to me like an overriding theme was also in the process of doing all these migrations, you kept on. It was very difficult to make things simple, but in the process of making things simple, you could actually literally choose the simplifying operations over performance because you actually no longer had slow pipelines in the process. I was just wondering, is there anything else you'd like to add to that sort of that theme per se then?
Theme, yeah, I would say theme is correct. We were trying to, first of all, reduce our technical footprint, right? Our technology footprint. We decided, okay, we want to run everything in Spark. We don't want to have Hive, Impala, Spark, Ruby, you name it, right? There's probably something that I forgot to mention there. We didn't want that. We want everything in Spark, one set of tools to monitor, one set of logging tools, etc. But the only thing I can add to that is maybe details if you're interested in those.
No, absolutely. I mean, we've in a lot of ways the session has been those details, but is there's anything else that you'd like to add? So it's just sort of from a call out point, yeah.
So a couple things that like maybe just call out some things that we didn't have to solve as we were moving over. We were originally thinking how we're going to solve this, and then we didn't have to. So to start with, we have lots of jobs that are templated SQL. And when we were starting the migration, Spark 3 wasn't around. So we were looking at them and saying, let's analyze their run times. The ones that don't take much time to run, we'll keep them as is. Anything else that's taking more than X minutes to run, we'll have to go dig into them. We might need to convert them to Spark jobs, do a bunch of optimizations here and there. And then Spark 3 comes out and it's like, yay, we can just turn on automatic optimizations and just throw it at it. All of the adaptive query execution, all of the dynamic partition pruning, like all of those optimization techniques that just come packed with Spark 3, that release was like awesomely timed for us because it allowed us to just say, oh, okay, no need to do this work. The next problem we had to solve was, let's say, we talked about it a lot, optimizing our outputs, right, in the previous session. But now we can just turn on, hey, automatically optimize our outputs, and we don't have to solve this problem. So that allowed us to keep pretty much almost 100% of those SQL templates as SQL templates without introducing this let's make it now a more complex Spark job with lots of micro optimizations within it, right? So, and now we don't have to maintain it. We can keep the maintenance on the original creators of these jobs because they can do it. That also allowed us, that also means that all of these jobs are now running faster. This attributes to the fact that now our pipelines run faster. Another thing that we achieved with this migration, we talked about it in the previous session, is workload isolation. So because our workloads are isolated, we basically schedule each job on its own cluster. We don't have this fighting over network I/O between jobs. We no longer have to limit the concurrency of our tasks. In our legacy system, we had to limit the concurrency of how many tasks we can run in parallel, because if we don't, they'll just chew each other up, right? They'll be fighting over resources. So all of those things basically translate to now our DAGs run faster. Let's make them simpler, right? So we can actually, it's also as a company, we're growing and maturing. It's no longer, hey, there's this 10 guys that know everything about every piece of the system. It's now, hey, we have this hundreds of users now using this system, and let's partition the work, let's partition the knowledge, but make sure that we have tools and guards in place to make sure it still works and they don't interfere with each other.
I think that is a great way to finish today's session. This is perfect. I really appreciate the advice that you provided. Stas, Alex, again, thank you very